Okay, so in the last video, we learned how to make these class limits and take a data set like this one over here and put it into the frequency distribution table. All right, so in the next video, we're going to now look at some variations on that. You can see I've cleaned up that frequency distribution table, typed those values in, and now we're going to work on a relative frequency distribution and a cumulative frequency distribution. So, first, let's talk about what a relative frequency distribution is. What that is it's going to be the same left-hand side class limits, but where I see relative frequency, what you can think of when you think of relative frequency is it is percentages. Okay? So, like I said before, we are going to have the same left-hand side. Let's see if I can get these copied in there. That's not going to work for me. Okay, so I'm going to take a second and I'm going to copy those values over. Okay, so now that I've got those values copied over, what we're going to have on the right-hand side is, again, rather than the number 3, I want to know what percent is this of the overall data set. Well, to be able to do that, I've got to get all these numbers and add them up. So let's go ahead and do that. It's going to be 3 plus 3 plus 4 plus 7 plus, whoops, 7 plus 8, I think is the last one. So let's change that to an 8. And that gives me a total data set of 25. So I have 25 numbers in my list. I had 23 written here. That is not correct. These are actually, these are going to add up to 25. Sorry, switching to the pen now. All right, so we know there are 25 total. We had 3 in this first class, so it's going to be 3 divided by 25. That will get you the decimal equivalent, and then we're going to multiply that by 100. So 3 divided by 25 times 100. You can do this with me. I would encourage you to do this with me. Okay, so that is 12%, right? So this first one is going to be 12%. Again, you might see this written as 0.12, but some have the decimal equivalents, but we'll do the percentages here. This will be 12% as well, right? Now we're going to do the next one, which is 4 divided by 25 times 100. Again, you can see that 4 comes from that right here, and then we're going to go over and figure that out. 4 divided by 25, because that's the total number we have, and then we're going to times that by 100. Again, this is just a basic percentage problem. All right, so this next one would be 16%. All right, I'm going to go ahead and work out the next two. Why don't you hit pause in the video, you work out these next two, and let's see if you get the same thing that I got. Right, so we're going to take a look, and here's my work for the other two right here, but you can see between 15 and 19.99, there's 28% of the data, and then between 20 and 24.99, we have 32% of the data. Again, this is pretty useful, but it just lets people know, hey, just seeing it rather than just numbers, especially when you have a big data set, sometimes it's nice to see percentages instead. So one thing you can always do to check is if you add these up, these should add up to 100%. If you rounded it, it might be slightly over or slightly under, but should be pretty darn close to 100%. All right, so the next one doesn't show up too much, but it is called a cumulative frequency distribution. You'll see why in a second. So the first class limit in the frequency distribution is going to be all the numbers less than 5. Again, you can see that that's the start of the next class. So we're going to follow that pattern. So the next one will be less than 10, the next category less than 15, then 20, and then finally less than 25. Okay, so now what we're going to do is to find the cumulative frequencies. We're going to, how many numbers in this list up here are less than 5? That's going to be these right here, right? So there are 3 of them. In the next category, how many of them are less than 10? Well, it's those ones I circled above and these ones. So what we're going to do with a cumulative frequency distribution is we're going to accumulate or add. So that would be 3 plus 3. There were 6 numbers or 6 data points that were less than 10. The next one would be 3 plus 3 plus 4, which is 10. Numbers were less than 10. Continue this on. And the next one is 7, so that would be 17. And then finally, when I do 3 plus 3 plus 4 plus 7 plus 8, I should get 25, which corresponds to the number of data points in my data set overall. It kind of gives you an idea of how fast the data set grows, but again, we don't see these too often in the real world applications. If you do find one, please send me an email and let me know. I love to see examples of like this out there. So anyway, we're going to work on organizing those frequency distributions. We're going to take a look at some shapes of data as well, and start to talk about the shape of this data in the next video.